Good morning. Good morning, everybody. Good morning, everybody from London.
Nada, sí, porque veía que no te conectabas, pero te he visto la cara, digo, vale, pues ya está.
Maria, you have to turn your microphone off, please. Thank you. Good morning, everybody from London. This is David Newman. I'm the Managing Director of BBIA. I'm very pleased to welcome you all this morning to this webinar, in which we're going to talk about the usable packaging project and its development after the first year of activities. Now, normally we would be doing these sort of activities in seminars and in conferences and in personal meetings all over Europe. But of course, something happened that you all know about in the last few months, and that means that we have to change the way in which we communicate and disseminate with you. This is also perhaps an easier way of disseminating with you because it is quicker. It means you can do this in your front room or your office, wherever you are. And you will have the ability to be able to ask questions. Now, on your screen, if you look at the menu where it says attendees, you will see a little button under that where you can raise your hand. If you raise your hand during the time of one of the speakers speaking, I will then enable you at the end of that presentation to ask that speaker a question, okay? So please feel free to do that. We have time for maybe 2 or 3 questions to each speaker. So please don't be disappointed if I cannot get all of your questions across to the speakers. We have a very good panel with us today. Very pleased to welcome Dieter Brigitte from the BBIA, which is the organization, the joint undertaking of the Commission and industries that is financing our project. Welcome, Dieter. Professor Jose Lagaron, who is the team leader for the project. Dr. Fabiana Fantinel, who is with David Bolsonaro and Alessandro Caffanini, work package leaders, and they will be presenting their work packages. I will be here moderating and keeping the time, and I guess that we will have about 75 to 90 minutes together. So get your cups of coffee, get ready, and here we go. Please, firstly, to welcome Project Officer from BBIA, Dieter Brigitte, who will talk to us about the future, the past, the present of bio-based packaging and the work that BBIA is doing. Welcome, Dieter. Over to you.
Now it seems to work. Perfect. So good morning, everyone. I hope everyone can hear me. If David doesn't start shaking his head, then it seems to be okay. Perfect. So good morning, everyone. My name is Dieter Brigitte. I'm one of the project officers of BBIA, the Bio-Based Industries Joint Undertaking. I'm actually not the project officer responsible for usable packaging. That is my colleague Antonella Canalis, but she's currently enjoying a very well-deserved holiday. So today you are actually stuck with me. So what I would like to present in today's presentation is a very short introduction or reintroduction in a couple of slides about who we are as an organization, what is BBIA. And then I would like to talk a bit more about bio-based packaging, how BBIA sees bio-based packaging, how have we seen it in the past, present, and the future. So let's first start with the introduction or reintroduction for some of you about BBIA, who we are and what we do. So we are actually a public-private partnership. Our aim is to strengthen sustainable competitive bio-based industries in Europe. If you're a public-private partnership, that means that you have a public partner and a private partner. Our public partner is the European Union, and our private partner is an organization called BIC, the Bio-Based Industries Consortium. And it's a true collaboration. So these two partners got together, they set up a separate legal entity, which is BBIA, and they devised a very specific mission for us, that is using Horizon 2020 rules. So Horizon 2020, the largest EU funding program for research and innovation. And they say use these rules to implement a document called the Strategic Innovation and Research Agenda. a document developed by industry and validated by Commission. So if you want to know more about BBIGU as an organization, you can find a lot more information on our website. Now, we act as BBIGU as a de facto funding agency. So yes, we do provide some policy inputs, but our main focus is on operational aspects. So organizing yearly calls for proposals and following up the projects that come out of these calls for proposals. We fund different types of projects on different levels, technological and others. So we fund research and innovation actions. So there the goal is to come to a validation of a technology on a laboratory scale. Besides that, we also fund other types of projects, the so-called demonstration type project. And there the idea is to upscale the results of these, let's say, validated technologies on a lab scale, and to see, can you indeed try to upscale them to higher volumes. Third type of projects that we fund are the so-called flagships. They are first of a kind, large-scale production facilities in Europe. So you see that, you know, we start from the lab, we go into upscaling, and in the end, we want to have real commercial operations, something that is new, that is first of a kind in Europe. And besides these three more technological type of projects, we also fund a fourth type of project, which is the so-called CSAs, the coordination and support actions. As I said, they're non-technological, but they support the other types of projects. For example, in the past, we've had CSAs dealing with communication. If you're asking people, okay, what is bio-based packaging? If you're asking 10 people, you might get 11 different answers. So informing people about what it actually is quite useful. We had CSAs dealing with, let's say, roadmaps for the chemical industry on how to deal with bio-based. So, you know, these types of non-technological yet very relevant projects to facilitate the further market uptake of bio-based products. We're a fairly recent organization because our first call for proposals happened in 2014. Currently, our last call in the current incarnation of BBIGU is open. That's called 2020. That's open until the 3rd of September 2020. I'll say a couple of words later on there as well. But here you see, let's say, the general overview. We mostly had a yearly call. In 2015, we had a split call. So every year we organized this type of competition where a list of topics was published. Organizations could then submit proposals, and then the highest scoring proposals were then invited to become ongoing projects. So this was just a very brief overview of BBIGU, who we are, what our purpose is, and let's say what we do. How does that relate to bio-based packaging? Let's first have a little look in the past. Topics. So as I said, every year BBIGU published a list of potential topics, inviting organizations to submit proposals. And since BBIGU starts, call 2014, packaging was already very visible there. We had a specific topic, the D3 topic, that dealt with packaging, bio-based packaging. Now, in the past, you know, you will see in our topics, in our yearly annual work plans, you will see the obvious topics dealing with packaging, like the one that I just mentioned. But there are also quite a lot of, I would call them indirect topics where the word packaging might not be explicitly mentioned, but where the results of the project actually really help the bio-based packaging industries in Europe as well. For example, topics and projects dealing with better processing technologies. You know, packaging might not be explicitly mentioned, but very useful results nonetheless. But also these CSAs, these coordination and support actions, they could also benefit everything that is happening in bio-based packaging in Europe. That being said, in the past, you know, well, BBIGU, we use a budget line approach, meaning that we do not assign a budget per topic. In other words, if you look into the different topics that we have published in the past, and you see that there is a packaging topic, it could be that for that specific topic, one, none, maybe more proposals were submitted. But you know, if no proposals are submitted, of course there won't be any projects. But even if there are proposals that were submitted, that did not necessarily mean that a submitted proposal would result in a funded packaging project. So, you know, you could think, okay, let's have a look at the annual work plans in the past of BBIGU, look for packaging topics, and then try to spot the projects that are dealing with packaging. But you might not really find those projects because of, for example, this budget line approach, because of the fact that for some topics, specific proposals might not have been submitted. So let's look where we are today then. So today, the status today in BBIGU is we have 123 funded projects. So that is call 2014 to call 2019. Some of these projects have already ended, whereas others, they will still run into the very deep future, even until June of 2025. And that's even excluding the projects that will still come out of call 2020, the call that is currently open. Of these 123 projects, we have all the different types of projects that are represented: CSAs, RIAs, demos, and flagships. So the question is maybe, okay, that's all very well, 123 projects, but where and how can I find information about relevant bio-based packaging projects? And that is very useful for the audience here today, because how can you keep track of what is happening in your field? How can you potentially identify your competitors or maybe future colleagues that you can collaborate with? How you can keep track of the state of the art, what is happening? How can you look for partners to collaborate in the future, maybe even find specific business partners? So to inform that, I would like to highlight two sources of information. That is the BBIGU website, where you have a specific section on the projects, and also Cordis. Looking at the projects, if you go to our website, in the main menu, you can see that there is a heading called Projects. And I'd like to draw your attention to the free text search function at the bottom left. If you would search for packaging there, what you would get is a list of 31 projects. So think about it. Of the 123 projects that BBIGU has funded or is still currently funding, 31 have the word packaging. And of course, since it's BBIGU, that will be based on bio-based packaging. So that's actually quite a lot of projects, a high percentage of projects that is dealing with packaging. And if you delve a bit deeper, you will see that there's actually very diverse. Again, all 4 types of projects are included there: CSAs, RIAs, demos, and flagships. Projects that have already finished, but also projects that will only start in September of this year. Now, and in that list of 31, some relevant ones are not even mentioned in this search because the project description might not include the word packaging, but still the results of some of these projects might still be very relevant for you. So you'll be very happy to hear that I will not go through these 31 projects, but I would like to just quickly highlight 4 of them for you to understand, a bit of a flavor, and I will use 1 per type of project. So you will already hear enough about usable packaging, so I won't even explicitly mention them here, but just for you to know, we have research and innovation actions. For example, this project, Hyper Biocode, has already finished, but there they were indeed looking for functioned hybrid polymer coatings for food and other types of packaging. You can find more information on their website. We also had demonstration projects. The fantastically named Deep Purple project, which is still ongoing. This is a demonstration project, so upscaling certain activities, where they are looking at different types of bio-wastes and seeing how they can transform them into sustainable materials, including packaging, using purple photobiorefineries. You also have flagships, so these first-of-a-kind biorefineries in Europe. For example, the Pefference project, which is still ongoing. There they're making a very specific type of chemical, which can then be further used as a bio-based building block to make PEF. And that's a bio-based polyester to make, for example, bottles that can be used in packaging. And then lastly, I mentioned that some of the projects still need to start. Well, this is one of them. This is a coordination and support action, All Things BioPro, which will only start in September of this year. And there they will actually focus on food packaging of one of the 4 tangible themes that they will use to work around. So as you see, a very diverse set of projects that are very useful for you. You might know or not know about Cordis. Cordis is actually the database that is used for, let's say, all EU-funded projects, research projects, from the first framework program until Horizon 2020. And of course, another valuable tool to look for all types of projects that are dealing with packaging, not only BBIGU projects, but for example, you go to Cordis, you search for packaging, you get a whole list. Very interesting, again, for you to keep track of what is happening in your field and to see what is happening also with bio-based packaging. So what then does the future bring? First of all, call 2020. in Call 2020, you again have some what I would call obvious topics that are dealing with bio-based packaging. For example, the D4 topic, specifically looking for superior bio-based packaging solutions. And this is one of the upscaling the demo projects. But there are also a couple of indirect topics that could generate some very useful results for you. For example, there is a CSA dealing with bio-based education centers. Now, bio-based packaging is a significant issue. It's also very relevant to ensure that the right knowledge is available and is being transferred and is being included in education centers as well. So the results of any potential projects that might come out of this topic could be very useful for you. There's another CSA topic looking at the underexploited circular bioeconomy. Again, something where bio-based packaging could play a role in. So please do keep an eye on the Call 2020 projects. They will typically only start somewhere in May or June of next year. But again, something very useful to keep track of. And then, of course, the question, and maybe there might be some questions that come from the audience as well, what will happen after Call 2020? That's a very good question, because in its current incarnation, BBIJU only has, let's say, Call 2014 until Call 2020. We will still run as an organization for a couple of years because, of course, all the projects that are still ongoing and the projects that will come out of Call 2020, they will still need to be followed up. There will still be very relevant results that come out of that. But what the future brings, that's a very good question. We see positive signals, but there's also still quite a bit of uncertainty. And hopefully in the next couple of months, we will be able to communicate about that in more detail. That's it from my side, just a brief overview, brief introduction of where we are right now as BBIG when it comes to bio-based packaging. Happy to answer any questions that you might still have.
Thank you, Dieter. Thanks, that was very quick and a very broad overview. There are two questions from my side. The first is, you haven't mentioned, unless I missed it, you didn't mention the value of the investments that are made year by year. Could you give the audience some sort of idea of the value that you think will be on the 2020 call, or the value of investments that were made in 2019, for example?
When you mean investments made or value, do you mean the total amount of funding given to projects?
Yes,
or...
the grant funding.
Oh, very good question. Honestly, I wouldn't know, for the simple reason that some of the projects are still ongoing. So of course, part of the funding is not yet paid out. There's a certain amount, let's say, that is provided. Some of the projects as well are dealing with packaging, but that is only one of their end products. So
generally speaking, what was the budget of the BBIJU generally, overall, not specifically for
that way? Well, actually, there we can quickly go back to this one here. So here you see the overview of all the calls. So here you can see all the different
the left-hand column. Okay,
yes,
it was small and I didn't see
the amounts that were pledged per call. Now, of course, roughly speaking, but again, since some projects are still ongoing, since some projects are focused on packaging and other things as well, how do you count the indirect ones? But look at the total amount that you see here in the left-hand corner. If you see that at least 31 projects of 123 are currently dealing with packaging, I would say that, roughly speaking, you could say that about a fourth of the budget is linked in one way or another to bio-based packaging, at least. But again, some projects are more diverse than only packaging.
And of course, on top of that, you have the financing from partners themselves, because that is not 100% of each project. So your 102 million could, for example, be 150 or 200 million by the time other partners have put their money in. Yeah.
And even more than that, because one of the things that we also evaluate during the call evaluations are especially for the demonstration projects and the flagships, are the so-called additional investments. So additional investments are investments that are triggered by the project. They are not included in the project budget, but they are triggered by the project. That will help to maximize the impact of the project, because that's what we see often with these bigger projects like demonstration projects and flagship projects. The BBIGU funding is a catalyst to ensure that there is actually more funding or more investment that will take place. Often, taking the first step of building the biorefinery, that is the tricky part. That is sometimes difficult because there are some technological uncertainties, there are some market uncertainties. This is why funding in general even exists, you know, to give that extra, let's say, incentive to actually do something that in purely economic terms might not be fully rational, but thanks to funding, you're actually able to make that investment. You are then also seeing if it works. You can then see that additional investment is also attracted by these types of investments.
Thank you. The second broader question, we mentioned it before the webinar started, and some of us are very concerned about this schizophrenia which there is in the European institutions. On the one hand, here you are financing bio-based packaging research, and on the other hand, we have instruments like the Single-Use Plastics Directive, which is making it very clear that bio-based and biodegradable plastics are not welcome. Certainly in terms of what the DG Envy is saying. How do you explain to researchers and to people who are involved in these projects this schizophrenia?
Well, this is also why we fund research, because there is uncertainty, because there are certain elements that are not yet known. Single plastic is one thing, but we know that some of our projects as well are dealing more and more with, okay, how can we ensure that bio-based plastics become more recyclable or become biodegradable? So these elements are also typically part of our projects, and it's only by funding these types of new developments that you will come to a clearer perspective of what can and cannot be done. Of course, it's true that politics, plays a role there. That new developments, new societal trends will continue to play a role there as well. You could state, for example, that the enthusiasm that there was 15 years ago about, for example, biofuels is also a bit different than it is today, because there have been new trends, there have been new insights, there have been new societal requirements for that. But again, this is why we fund also research projects, just to make sure that all policy can be based on the most recent developments. And as I said, compostability, recyclability, biodegradability, they are often important elements in bio-based packaging research.
Thank you, Dieter. Jose, Chema, did you have any question, or David, or Fabiana, any question for Dieter? No? Jose?
Go ahead, David.
Okay.
David Bolsonaro wanted to say something. David?
No, he said he had no question.
No, fine. Yes, well, I was kind of worried a little bit also about the fact that what just David mentioned. I know that you answered that there is a knowledge that needs to be built, but Dieter, I think we have already a lot of these projects running for over 10 years or more now. And there is a very clear evidence that some of these biopolymers, particularly the ones that we're using in the project, PHAs, offer unique differentiation in the world of bioplastics, for instance. And all bioplastics are not the same. They have particularities associated to today. And there are issues like, for instance, PHAs not being considered a natural polymer, and there are the technicalities about the definitions and things like this. How do you leave that from the political viewpoint? Because right now it has reached this arena.
Well, also there, let's say me working for BBIGU is a bit tricky for me to reply to that one. Why? Because our mission is fairly operational. So how do we work, or how did BBIG work until now, until Call 2020, is you had on the one hand BIC, Bio-Based Industries Consortium, on the other hand Commission. They discussed together which were the topics that should be included in the yearly lists. So we as BBIGU, at the end of the year, we receive that list, and then we make sure that the evaluations can take place and that the projects that come out of that can be followed up. So the policy developments on that stage, yes, we do provide some policy feedback based on the results of our projects, but how those will be taken into account, very difficult with the mandate that we have as BBIGU to comment on that.
Okay.
Thank you, Dieter.
Thank you, Dieter. If there are no more questions, then I would like to thank you, Dieter. Please remain with us if you wish to. And now we are going to go into the nuts
Sorry,
and bolts.
David, an attendee is asking a question. Majone Moro.
Mauro. Sorry, I didn't see that. Mauro. Yes, please put Mauro on. There is a question from Mauro Majoni, a professor at Rome University for you, Dieter. Please put him on. Mauro, can you hear us? Mauro, can you hear us? I think, give him a second, he will be with us. Mauro.
Okay, sorry. I have to activate my mic. I suppose now you can hear me.
Yes, we can hear you.
Sorry. So my question is about the policy of BBI, the so-called budget line. Because let me say honestly that from the point of view of people applying for some topics, it's really uncomfortable to not know in advance how much budget will be available for that topic. Because to prepare a proposal requires a big time effort and investment. So I really don't understand why, if I overcome the threshold, there is another competition in which I can't do anything. And so I can have the situation, actually I had this situation in the first call, that you are above the threshold and you are not financed, although you have no better competitor than you. So it's really difficult to understand this policy on my side.
There are pros and cons to every approach. I worked for the European Commission before, and there in the topics, let's say, or in the calls that were organized then, there was indeed more of an approach where we had a budget assigned per topic. Now, in Horizon 2020, I've seen in different programs, by the way, not only in BBIGU, where the budget line approach was used. The main advantage of a budget line approach is the following. So suppose that in a budget line, there are 5 topics. So then that means that every proposal is in competition with all the proposals submitted for all these 5 topics, not only for the topic that you are submitting. Now, suppose that for one topic, there are 2 fantastic proposals that are being submitted. One scores 15 out of 15, the maximum score. Another one scores 14.5. Another topic, there is one proposal that is submitted and they barely go through the thresholds. They score 11 out of 15. The advantage of a budget line approach is that only the best scoring proposals will be funded. So in that case, we would fund the 15 out of 15 and the 14.5 out of 15. The 11 out of 15 would then not get any funding. So again, it depends on, let's say that there are pros and cons. Yes, if you would assign a budget per topic, you might have a bigger spread of projects. However, you might not necessarily be funding the best proposals. And that is the discussion that, again, you know, I understand your concern. This is there are pros and cons to every approach, but the budget line approach is an approach that was chosen at the start of BBIGU that we have used throughout all the calls that we have done so far, and that we will also keep using in call 2020.
Thank you.
That answers your question.
Yes. So my question was, so you plan to maintain also for the future? So there is no evaluation to change in the future this approach?
The only future that I can talk about right now is call 2020.
Yeah, okay.
Because for the rest, let's say there are a couple of uncertainties. There are positive things, you know. Well, let's address the elephant in the room. Will there be a successor to BBIGU? I don't know. That's the only honest answer that I can give. Do I see positive elements? Yes. I mean, if you look at the Green Deal and everything that is published there, of course, content-wise, there are a lot of links to what we as BBIGU are currently doing and what a potential successor could contribute to the Green Deal. However, as you know, Europe works with 7-year budgets. Currently, the discussion is ongoing about the next 7-year budget. And it's great that we, you know, when you look at the content discussions, that we are somewhere there. But as long as the budget isn't clear, we don't know if and how much money will be available to carry out all these great ideas that have been put forward linked to a potential successor. So in, let's say, by the end of the year, we should indeed know more. But at this moment, I wish I would be able to tell you that there will be a successor. I just don't know. And of course, as long as that is not known, I also don't know what the policy will be in the next calls, when the next calls will be. Will there be a budget line approach or something else?
Thank you.
Thanks, Dieter. Thanks for joining us, and please stay with us.
Yes.
And please now, if you would mute your microphone, that would be very kind of you. Thank you. Welcome, Jose. I call you Jose because people will not understand why I would call you Chema, because the name on your photo is Professor Jose Lagaron, who is the project leader. Before I pass over to Jose, I have one message for Alessandro Carfanini. Alessandro, you have to log out of your login that you are in at the moment, and you have to log in with the personalized login that Alison has sent you. Otherwise, you will not be able to speak later. So Alessandro, if you've got that message, you have to log out and log in with your personalized login to be able to speak. Jose, over to you.
Okay, good morning, everyone. Thank you, David and the BBIA for organizing the webinar, this interesting webinar related to the project. We're living very interesting times in which, well, these webinars have become popular ways to really disseminate activities, and to some extent, I think they have the ability to reach out very efficiently from my experience. So thank you also, Dieter, from the BBI GU for staying with us and introducing all the activities that were not necessarily known to everyone and that offer interest. So what I would like to do is to present briefly the usable project, strategies and objectives, and also to some extent achievements so far done within the project. And I'm very thankful for the work package leaders to be available and then to go into more detail regarding the specific activities done, but also getting a deeper understanding of what the different work packages within the project are all about. Okay, so the how is this not changing? Okay, so usable packaging is a BBI project of the Horizon 2020. It's a 3-year project which started the 1st of June and will close, or has been scheduled to close on the 31st of May. Let's see what happens in the end, because these 3-4 months in which most or many of the partners in the project have not been allowed to work will give us some uncertainty as to whether there may be some extension or not. But many of the partners have been active, and everybody is been really pushing hard to do in as much as possible within this strange scenario that has come upon us. The project brings a consortium of 25 partners from all over Europe. I am the coordinator, or at least the scientific coordinator, and been helped a lot in the organization and in other activities by Fabiana from InnoX, for which I would like to thank her. And the key objectives of the project is to develop bio-based packaging products that are biodegradable, compostable, or that can be recycled through organic recycling. So the project, as we know that packaging, so initially disposables have been on the target line of a lot of let's say vectors in action here, especially by consumers and retailers, and I think now is the whole industry has been involved and concerned. We all know about the issues that packaging and some disposable items The shelf life is very short. For instance, packaging is considered to be in use something between 15 minutes and 6 months, and then it becomes waste. So as you can imagine, being food packaging one of the biggest, in fact, consumption sector for plastics, leads to a significant amount of waste floating in the oceans and somewhere around in the environment. And everybody who is a little bit knowledgeable into polymers, especially petroleum-based polymers, there are two main characteristics associated to these polymers. One of them is that they are very inert under environmental conditions. So that means that they may stay in the environment without significant changes for a number of years, hundreds of years, or even more. And then the second aspect of this is that when they are reprocessed, when they are submitted to high temperature in the processing machinery that the industry uses, eventually degrade, and then they become unstable, and they may be problematic from a food safety viewpoint. So because of these two things, bio-based packaging that makes sense if we are able to define the proper end life scenario. And organic recycling is one of the things that we are trying to boost within the project. And so if I just show you the objectives, the idea of the project is to create a portfolio of biopackaging solutions, in principle for food, drinks, but not only for that, also for pharma and clothing, as we can see there. So from this point of view, the project is very broad. The idea is, as I was mentioning before, and I am sure that David will discuss a little bit more about this, is to define a clear end life scenario, options for these packaging materials that are radically different from what is happening today. So today, the two options that we have is either we continue to use this petroleum-based plastic and risk that 30% of it will end up in the environment, or we can actually run strategies on the circular economy where we try to recycle mechanically, mostly, which is currently the main way to reuse this packaging, to reconvert it into new packaging by processing. Then we have the issues that we discussed before, where by recycling, there are a number of times that one pellet of a conventional polymer will be able to withstand. For instance, PET is considered to be about 7 times, and then after that, then we may start having issues. So what we are trying to offer here is a different scenario where these materials can have a different end of life option, which is relying more into what is called biocircular economy, where we are actually taking waste and then bring it back, valorize it, upcycle it, and then bring it back to waste, therefore closing the loop and offering this organic recycling scenario that we would like to promote within the project, which will be an alternative to recycling of the traditional conventional plastics by reprocessing. The definition, so in a way, what we're trying to do is biochemical recycling in a way, because the nature will bring the polymers back into the monomers, and then the nature again will bring them back into the polymer. So in a way, it will be the equivalent to the chemical recycling scenario. So the idea is to have vertically integrated all these activities and then allow them to become circular. Of course, the project is based on the use of this amazing polymer to many of us, which is called polyhydroxyalkanoates. Polyhydroxyalkanoates are produced within the biomass, within microbes, within microorganisms. So it is fully synthesized within biological systems and as an energy reservoir. And then, of course, this explains why when the PHAs are found or are dumped into nature or buried into the land, in landfills, etc., the microbes, they find it and they eat it because in a way it's the food that they have designed into their biomass to be used for such. The idea then is to take these PHAs that we obtain from different food waste components, agricultural and other sort of wastes, and convert them into PHAs of different with different properties. So the idea is to get a toolbox of PHAs that by blending them together will allow us to get the property balance that are required for many of these packaging applications. So the idea then is to transform these PHAs into upcycle them into really valorized packaging items that can completely substitute the current solutions that the packaging industry has been doing for many years using petroleum-based plastics. Then the idea also is to generate bioadhesive layers and to reduce the environmental footprint by understanding how this is being impacted, and of course try to minimize it. And well, again, life cycle analysis, understanding, etc. So will allow us to be more carbon neutral, water neutral, etc. That is, let's say, our objectives. Okay, so here is the circularity we propose. We start from fruit processing side streams, so basically wastes or byproducts of relatively low value today, convert them by microbes into PHAs. Then the microbes are, of course, naturally derived also. We are not promoting here any GMO type of microorganisms. So in a way, we isolate them from nature. We convert them into PHAs. Then we functionalize them by using different additives that are also meeting this criteria. Eventually, they are upcycled into packaging items, which has the value to extend the shelf life of different products. And then eventually they're being used by consumers. And we hope that the end life scenario of this organic recycling will take them with the rest of the organic waste into composting plants to become again and close the circularity, to become again a waste that can be used again to produce new PHAs, etc. So that is our scenario. So then the idea is to get a new value chain that will cover all these different applications. As a base material, I already mentioned widely that we will use different PHAs. At least 8 types of packaging items will be generated using different technologies like blown film, electrospinning, roll-to-roll lamination. So there are some innovative ways of processing these bioplastics in a way that will overcome some of the issues that the long-term research carried out already in this material has highlighted. And then we will be trying to use these innovative processing technologies, these innovations in the processing side, so that we are able to come up with these different solutions, functionalization of some of these materials. Again, having in mind all these green scenarios, these bio-based scenarios in our head, will help us to tailor the properties so that eventually a number of applications like hot tag films, medium barrier food packaging, high barrier food packaging bags, pharma liquid sachets, etc., will be developed and to a point where the industry can take it further and convert it into real products at some point soon after. So the main objective then is to reduce the environmental footprint, the creation again of this portfolio of bio-based packaging solutions that will serve all these industries that are in there: food, drink, pharmaceuticals, and clothing. The development of this complete value chain on the basis of the application of these PHAs, optimization of the PHA functionalization to be able to match the end use, and then a very clear scenario of disposing of the materials with a strong focus on the organic recycling. Here are the partners involved from different countries: Italy, France, Spain, Portugal, Belgium, Croatia, Greece, Poland, Switzerland, Turkey, United Kingdom. There are universities, there are technological institutes, there are SMEs, and there are also large industries all along the food chain to be able to really assess with the most certainty the value of what we're doing and really extract the highest value possible to the work. There are 7 work packages. Some of my colleagues will dwell into some of these work packages after I finish my presentation. But in principle, work package 1 is the collection of input data and knowledge of bio-based polymers and end products. Work package 2 is sustainable production of pure PHAs. Work package 3 is functionalization of this building. Por favor, ¿puedes dejar de hacer ruido? Sorry. Work package 3 is functionalized building blocks for complex packaging structures. Work package 4 is usable packaging performances in real usage and end-life conditions. Work package 5 is exploitation. Work package 6, communication and dissemination, and work package 7, coordination. So it's not very different from the typical structure that the European projects have, and that goes from the development all the way to dissemination, proper communication, and here is the example of, for instance, this webinar. The different work package leaders will come in a minute, so I will not go into details here. There is, of course, this strategy that the project has to be able to manage this complex structure with the highest standards. So we have the partners, we have the General Assembly, the Strategic Committee, Steering Committee, the coordination, on top the European Commission, and then a very interesting platform that David has created, the stakeholder platform, that of which we roll in the first meeting. We made the first meeting of all these stakeholders, and it's been very important for us to understand what is the perception of the outside partners, or really a major vectors into the technology that we are developing, and they're really helping us to refine the strategies and the activities that we do, so that they make more sense along the way. And then very briefly, I will show some of the developments that we have done within the project. For instance, we have developed PHA-based straws that can be biodegradable in the environment. We are actually proving that by putting them into the ocean and by checking the home compostability and the industrial compostability, the biodegradation standards, etc., by looking at how they disappear with divers into the ocean, and all of these activities are currently being carried out and will be carried out by some of the partners in the project. Then we have also been able to develop this cutlery based on PHA as well, that for the time being are a little bit fragile, but the next generation will offer a better solution here. This is all in the disposables area. Then we more recently, together with Geiker, which is one of the partners in the project, and the company that is subcontracted by Geiker, that we have developed these plates that are also based on PHA, that are reusable. So in a way, they can be washed and they can be reused, and they have sufficient strength, and from an application viewpoint, they are already ready to go. So this, we are very proud of having been able to achieve already these results. Then together with BioMe, we have been working also on film blowing and casting. And then we are doing some advances here, and BioMe is working very strongly towards achieving these films that are, of course, one of the most relevant elements that the packaging industry in general uses, and again, that all based on PHA. And finally, one interesting application where BioInitia is one of the partners in the project. It has this unique processing using high voltage, so we don't use temperature, and that means that in fact we can make layers, coatings over paper to, for instance, hydrophobize it, or super hydrophobize papers, etc. And this is the kind of innovations that the project would like to really highlight, because by combining these new materials produced from wastes or from byproducts, together with innovative processing technologies, will allow us to really get the significant performance that the industry is in fact demanding. And this is all I had to say as an introduction to the project. And I don't know how the questions are taken in the end or not, but I'm happy to answer any questions.
Thank you, Jose. I don't have any questions from the audience right now, but I think that they will come perhaps during the work package leaders. So I want you to stay online and be ready for that. But maybe this is a question more for Fabiana, who's following you, but just think about it in case she doesn't have time. When you talk to industries, and I know you're talking to the retail chain, you're talking to the packaging chain, you're talking to the distribution chain, are you seeing a substantial increase in interest around bio-based and biodegradable materials? Or do you think this is a passing phase and we will all go back to plastics?
Absolutely, David. I mean, retailers are at the forefront now of adopting these solutions. For them, it's no way back, because it was very funny. One of the large companies in the project, Sonai, which has this continent supermarket chain, the biggest retailer in Portugal. They were saying 5 or 6 years ago, when the consumers got into our shop, they saw all this packaging in this very transparent and nice, all these food items in this very nice and transparent packaging, and they associated that with cleanliness and with shelf life extension and quality of the product. Today, when they come into the shop, all they see is plastic that could go into the sea or into the environment, and therefore these are definitely the biggest promoters for this technology.
That's interesting how the perception has changed so quickly. Eh? Okay, thank you very much, Chema, Jose, and now Alison, I would ask you please to allow access to Fabiana. Fabiana Fantinella, who will join us from Germany. Welcome, Fabiana. There you are. Here we are. Welcome. We can see you. We can see your screen where you have a Word document, which I think is nothing to do with this. It's in German. So you better close that before you give away any confidential information.
Yes. So I've got 2 screens, so Eventually, that means that not my right screen is shown, so I need to bring that to the right screen.
We can see your screen
see
now.
the presentation.
And now we can see the presentation. Perfect. Thank you. Welcome, Fabiana. And for those of you who don't know Fabiana, she is going to talk about the work package number 1. I've been working with Fabiana on the previous project led by Professor Maggioni down in Rome, Resurbis, which closed at the end of last year. And she is, I think, probably one of Europe's leading experts on this, on the exploitation of these materials. Over to you, Fabiana.
Thank you, David. So I will present what we have done so far within the work package 1, and also we group work packages 5 since it's all in one presentation where we're working with David. But we start with the work package 1. So work package 1 is basically a work package which is the first one that started in the project, and is designed to collect information that it's useful to both to design the products and also to have data that are relevant for the exploitation. So first we look at the value chain of the project. Basically, we start from biomass, which is generated by the food industry, so not food waste, but biomass, which is like a side process stream of the food industry and of different types. And in one case, for Sone, these are spoiled fruit and vegetables from supermarket. But not mixed streams like municipal organic waste or other streams where there are several issues. So let's say these are clean biomass streams that are used as inputs. In this project, basically the biomass streams are provided by the industrial partners. We have industrial partners that are large industries, and they produce a side stream in their value chain, and we are looking at all of them in the project. So that's why we have a selection of different types of biomass. For example, bread crust and bran from Barilla. We have spinach leftovers from Orogel. We have vinaces from Caviro, and we have expired vegetables from Sony. So this is the first step of the value chain. And then we go to the second step of the value chain, which is basically the conversion of this biomass into biopolymers, namely polyhydroxyalkanoates, PHAs. And this is done by different partners, so Innoven at larger scale, and then other partners at smaller scale, and also with different task functionalization and so on. But I will not go into detail of this, which is not the objective of the presentation. So just to say, all the activities are around this PHA production and functionalization from biomass. Then there is a step of extraction, compounding, and finally packaging manufacturing. So in this for packaging 1, we look at the beginning, so which is the biomass, which is the type of biomass, related availability, costs, and so on. And at the end, which is the type of packaging which is produced through this biomass. In the grant agreement, we have described at high level the packaging types. And during the project, especially in work package 1, we go to deeper level of understanding, and we look at all the packaging types that are relevant for the large industries. What are the key features, the key properties and specifications that we need to take into account so that these products fulfill the needs of the industries that in principle can close the value chain because they provide the biomass and they would use also the packaging which is realized. So the goals of the work package, one in particular, are to create an inventory of feedstock available in Europe, and specifically from consortium partners. So we look at what is available from the consortium partners, but we look also at what is besides the consortium partners, so that we have a broader mapping and also more complete mapping of the possibilities. Then to map the process route for every stream of feedstock, so understand where it's more convenient from an economic point of view, mostly techno-economic, not only technical point of view, to produce the PHAs for the packaging. And then also to define the usage condition and then life options for the plastics, so that we know where we start and also where we end, and map the characteristics with respect to the end use that will be made out of them through the processing. In particular, in this presentation, I will show you what we did so far. We have basically 5 deliverables in this work package, which are associated to 5 tasks. And in particular, we have completed already 3 out of 5, and 1 is ongoing and 1 is not started yet. So in this presentation, we will focus on the completed task that led to some deliverables, and I will give you a short overview of the results. So in particular, going to the first deliverable, which is related.
Excuse me, interrupting. Could you put your screen share on full view, because it's very small. We can only see it's very, very small. I wonder if you can put it on full screen, and then we can see you and maybe the slide.
Yes, could you, because I've got 2 screens, so it goes in full screen in the secondary screen. Could you change the setting, please, so that you see my secondary screen, because otherwise you see the
that's okay.
web.
Leave it like that. But let's not complicate it, because we may lose you if we do that. Okay, just carry on, please. Carry on.
Because I don't know how to do that myself. I'm sorry.
No, that's okay. Apologies.
Okay, so let me see what I can do now. Just if I zoom, I'm trying to. No, it's not really good. I'm trying to solve the problem. 1 second.
Oh, don't worry. Don't worry about it, Fabiana. Please carry on.
Oh, thanks. Okay, so here we have basically the study that we did. We looked at the feedstock, at the biomass available in Europe, and we did a mapping starting from the partners involved. Since we have several partners in different countries, we studied mostly the countries where the partners are located, and looked in particular at the partners providing biomass. So some partners provide biomass, some partners utilize the biomass. And so we looked at a little bit at both, where the biomass is provided, how much is it, which type, and so on, which characteristics. And when it's utilized only, we looked at what other sources are available in that country for the biomass, so that we could have a complete map and a complete picture of the potential for the project at full scale. So in particular, out of this study, we looked at the biomass provided by the partners. So SONE, the Portuguese food distribution chain, which is a large industry, provides basically has the potential to provide the largest amount of feedstock, which is spoiled fruit and vegetables. And the volume per annum is about 3 million tons. So it's very large amount of feedstock. And their model is a group with several retailers and supermarkets, and it's based in Portugal. So for a full-scale scenario, this is a very good starting point of biomass sourcing. Then we looked at Barilla. Barilla is the second in terms of volumes, of quantity. And basically, Barilla is well-known pasta manufacturing and bakery product maker from Italy. And they are providing for the project bran and bread crust. And this has a total volume of 125,000 tons. So it represents 4% with respect to the total supply for the project we're seeing at full scale. Of course, so in the project we don't use such a large amount of biomass. Then we go to Orogel. Orogel manufactures and sells frozen food, so vegetables, fish snacks, and ice creams, and it's based in Italy. And in particular for the project, they concentrate on spinach residues, and the total amount of volume is about 2,700 tons. So it's relatively small with respect to the first two, but still a quite large amount for the perspective of full-scale commercialization. Then we have Caviro, who's manufacturing and selling wine and byproducts, and also doing transformation using the byproducts in the pharma value chain. And in that case, the volumes are relatively small, so in that case, it would not make sense a full-scale plant unless it's combined with others. For example, Barilla, Orogel, who are very close geographically, as they are all in Italy and also in the same region. So basically, the Italy cluster could contribute altogether for a future scale scenario. We are studying further the future scale scenario. I'm not presenting it yet because it's an ongoing work which will be completed in a couple of months. So basically, in concluding, for the feedstock availability, the feedstock biomass is widely available in Europe. Didn't present all the results. We have all the mapping also of other types of biomass that can be merged into these biomass streams. We look at the economic viability based on the feedstock provided by the consortium partners and also beyond. But first, the sourcing, the map for the sourcing looks positive, and actually this was one of the assumptions of the project, but it's confirmed in this first part of the study. We move now to the second type of activities that have been that of putting together the specifications for the prototypes to be produced during the project. So basically what we did is we contacted all the large industry partners. This is work done by Euromaterials, by Frederic Merrill as first person, and basically all the large industry partners have been contacted, and they have provided their wish list for packaging items to be realized by the project, and also the specification and some basic details on the processing route and so on for the packaging. So in particular, for example, Sphere has provided as a target item a compostable cap, and the cap basically should have some characteristics that the caps currently in use made of polystyrene have. For example, good strength and stability for hot and cold liquid. Should hold a volume from 9 centiliters to 60. The weight, the current weight is 1.5 to 9 grams in plastics, and they have also some other characteristics, like they should not change their shape if the liquid is hot, or they should allow microwave use and so on. And also they should have food compatibility, so according to the EU norm N10/2011. This is a more rigid type of material. The current polystyrene has a modulus which is above 3,000 megapascal, so it's quite rigid, and this is a more technical indication for the development. One issue here that I'm not really discussing in detail, but we had some discussions in the consortium in the past weeks and past days. Basically, PHA may not be permitted anymore as single-use plastic product, since PHA could, there is some discussion ongoing whether PHA is a natural polymer or not, whether natural polymers are permitted, if natural polymers are the only one permitted. I will not go in detail of this discussion because this is completely, it's outside the activities, but we will tackle also these aspects within the project, and we are already discussing and also thinking how we can contribute through our project on this field. Here we have a second item, also from Sphere Distribution. This is a compostable food tray. And in this case, the target material for substitution is polypropylene. The modulus is approximately 1,300 megapascals, so a little bit less rigid than the previous one. And we have some specifications of the volume, dimensions, weight, the thickness, temperature that needs to be, the item needs to be withstand, and shelf life. So we have several, we have actually a long list of those items, so I will not go through all of them, but just to show you the way that we have been working, so collecting for every large industry partner the wish for the prototype, and collecting the specifications so that on one side, the technical work packages will be able to realize items that are suitable for the purpose. And on the other side, we can study the economics around it and understand how we expect to position packaging prototypes with respect to the economics. Of course, the economics is projected at full scale, so it's a model calculation because the plant is not at full scale at the moment. So if we move to the next item, this is an item from Barilla. This is a flow pack for bread. This is also more flexible, and it's a substitution of BOPP film. And in this case, we have some characteristics that are very important and that are barrier properties, so that the shelf life is 60 days. Also in this case, food contact is required, and we have some characteristics in terms of thickness of the film, about the geometry and so on, and of course barrier properties that are not shown here, as this is very much detailed, but this will guide the development for the technical work packages, and also will enable us to calculate which is the expected price of a PHA-based substitute compared to the BOPP film, which is currently used. Now we go to the next example. Is basically a nice example. This is a result that comes from arsenic resins under the lead of CSIC, so Professor Lagaron. And this is basically what we did so far. One of the targets was cutlery. So we had this target from Sphere Distribution. Cutlery with good strength and stability for cold food and hot food, so if possible resistant until 70 degrees. We have some requirements on the geometry, so length, weight, the cutlery resistance, so the cutlery should be enough stable to keep strength during up to 2 hours. And more for reusable, especially with hot food. and has to comply food compatibility. Here the cutlery has been realized, and as you can see, looks very good. And I believe the test with respect to all resistance and also temperature, behavior, and so on is not completed yet, also because this was shortly before the lockdown, so is probably early March, really just before activities in the labs were stopped. But it's a nice result that shows we have a prototype. That's not the only one. There is also a plate. But the plan is to continue working on this mode. So we have a target, and we'll provide a prototype that matches as well as possible the specifications of the target, and so that we can assess from the technical point of view which is the potential for replacement, and also from the economic point of view how much this will cost, and if there will be an additional cost for the sustainability. So we have all the benchmarks across the benchmarks are mostly across the petrochemical industry. So what we realized during this study is that the large industries do not use other bio-based materials yet. They are willing to switch to bio-based, but they are currently using petrochemical materials. And of course, we look at the options. This is our option, and we look also at other options, other bio-based materials, which might be interesting. Of course, we are not realizing the prototypes in the project, but we study those at least from as test of activity, and also comparing the costs of the various options and the expected performances. In particular, it's very interesting that this approach would enable an intra-chain utilization from the industrial consortium partners, like for example, Barilla could provide biomass and would utilize the packaging, which is actually very efficient and also can provide better economics, less transportation costs, and so on. So the circular value chain has both environmental and also economic efficiency advantages. Now we are studying that more in detail and quantifying all those aspects. These are work in progress that we will be able to share probably in few months, the next occasion. Now I go to the last part of this presentation. This is basically the life cycle assessment. This work has been done by University of Santiago de Compostela under the leadership of Professor Almudena Hospido Quintana, and with her team, which is shown in the slide. So basically, in work part 1, it has been defined a framework for the life cycle assessment and the set of data that are required for completing this assessment. So the scope and definition, inventory analysis, impact assessment that will guide then the realization of the life LCA and the interpretation. So in particular for usable packaging, the LCA will comprehend several steps. We start from substrate production, so the biomass as residuals of food industry and vegetable and fruit waste in supermarkets, for example. Then the second step is pH production. Third step is pH recovery and purification. Then fourth step, bioplastic compounding and shaping into final items, so conversion of bioplastics. Then will be the use, the consumers basically, and the end of life, which is the disposal, where looking in particular at organic recycling in this project. So all these steps will be met, and the LCA of each step will be considered. In particular, there are, looking at this project, there are for the substrate production, so the biomass production, USC has divided that into 3 steps: collection, then pre-processing, and storage. And of course, having a circular value chain can shorten some of these steps, and so make them more efficient, and also reduce or even eliminate intermediates transport. So this is the framework that USC will use for the project, and the results will be later in the project and also in the work package 4, where the LCA is will be completed and re-performed, and as this is linked to the products and to the prototypes of the project. So this is basically all what I wanted to show you. Thank you very much for your attention, and pass the word to David. Or if you, maybe we can have some questions at this stage, and then we can continue with work package 5 stakeholder platform from David afterwards.
Thank you, Fabiana. We are running late, so I'm going to go into that next slide. If you would put that next slide on for me, Fabiana, just to explain to the audience who are with us that as you mentioned, and as Jose mentioned, we have a stakeholder platform which is now consisting of more than 50 entities from around Europe, industries, academics, and NGOs, etc. If you wish to, you can join the stakeholder platform. It is open. It is a free, open platform to anybody interested in this project. And we share with you the activities that are going on. And we ask you, as we have asked many of the stakeholders who are listening today, to reply to some of the questions that we have regarding the activities that we do. And the wider the stakeholder platform is, the better that is for everybody. The slide has disappeared, but don't worry about that. And then, of course, we have dissemination activities, which, of course, today is just one of them. We have many dissemination activities, and our organization, with my colleague Jocelyn, who is listening in, is responsible for the dissemination activities. And so if you wish to disseminate to our partners and to our stakeholders messages relative to your industry and your projects and your research, we are available to do that amongst our network, and we ask you also to disseminate our materials amongst your network. Regarding this particular webinar today, the presentations, I asked the presenters to send them to me in PDF, and we will load them onto the usable packaging website in the next few days so that you can go and see them. I realize that seeing them on a screen quickly over an hour is quite difficult, but we will make the presentations available to you. And we will be holding further of these webinars as we go forward, because obviously with the COVID-19, it's becoming increasingly unlikely that in the short term, many of us will be traveling to conferences, etc. So that is enough from me. I will pass the word now to David Bolsonella from Verona. Welcome, David. As quick as you can, run through the essential points on the progress on your work package. Thank you.
Yeah, I will try to keep it very, very fast and very easy, if I can. Well, thank you for everything. Okay, can you see my screen now?
Yes, everything we can see. Go ahead.
Okay, perfect. So, sorry, let me start from the very beginning. Okay, just a few words about work package 2, which is basically dedicated to the production of PHA, actually starting from, let's say, mainly food processing waste or residual material of this kind. The basic approach, as Professor Lamaron showed before, is that we have this situation where basically, I don't know why it disappeared. Okay, where basically you see here all the organic material, residual organic material coming from a given territory is then transformed into PHA, which is then used to produce basically packaging material or other similar bioplastic material. And at the very end life of this material, of course, you have two options. One option is that this material is again recycled and turn back to produce new bioplastic, or it is treated like organic, like other organic waste. So through anaerobic digestion and composting, for example, it will come back to fields in the very end. So it will come back into the carbon cycle. So in this way, you have a real circular economy approach, let's say. So having looked to the content of this work package, we have all an activity at lab scale related to the optimization of PHA production. We started more or less 1 year ago, but you can imagine because of the pandemic situation, all this work is basically delayed, unfortunately. And what is starting now, again with some delay, is actually an upper scale production of PHA material. In the meanwhile, in very brief, we will start also the third part of this virtual train, where we have the PHA extraction and purification, which is probably a very, very important step of this work package. In the very end, we will have a material will be available for the activities of work package 3 and 4. You saw before some activities, some samples of what you can do in terms of cutlery or film material, these kind of things. Once we have a good production of material, enough in terms of quantity, of course, they will be able to use also all the material coming from our experimentation. Just to give you an example of the timeline, this is what we were supposed to do. So let's say in this moment, we are around month 12. But imagine that because of the pandemic situation, all the first tasks you see there are all delayed, and the same is for the activity we should start now, for example, at the pilot scale. Deliverables, reporting results were supposed to be around month 70. Of course, because of the situation, they will be slightly delayed, but not that much actually. So let's say that around December, January next year, we will be able to show some of our results. Coming to details of the activity carried out so far, we have a first activity related to the acetylene fermentation of material coming from these big names of the food sector or beverage sector you see in the table, producing different byproducts material, sometimes rich in proteins, sometimes rich in carbohydrates. And in any case, what the guys in Rome, in La Sapienza, we heard about Mauro Moione before, what they are doing is all the tests you see here in terms of anaerobic fermentation in a acetylene condition to produce volatile fatty acid. This is the first step. Then after that, we will take this BFA and transform it into PHA. So this is the first step of the biological train. So this is a very important activity. And you see on the right here on the graph where results are very interesting, because in this moment we are able for sure to transform more than 50% of the COD, so let's say the organic material in these byproducts, into volatile fatty acids that will be then transformed into PHA. Of course, another important point is not only the quantity of this BFA, but also the quality. That means that having a different proportion of acetic, propionic, butyric, or valeric acid will give you different PHA with a different formulation and different technical performance. So that's another important step. Here you see some picture of the lab scale architecture here, some tests for this material. Here is always at lab scale a first PHA production in mixed culture conditions, something then we will scale up at pilot scale to have enough material for the test on machinery. Another important part is the one they are carrying out in Portugal by Nova ED, where they basically using Parpobacillium green bacteria. So let's say photosynthetic bacteria working in carcinogenic condition. What is interesting here is that these bugs are able to use CO2 and transform this CO2 into organic material like PHA with or without the presence of VFA. So imagine that you don't need to transform organic material into VFA, but you can use directly CO2. So it's very, very interesting way to fix CO2 from an atmosphere, for example, coming from not only biological processes, but also, of course, the fossil industry, for example. So it's another way to use carbon. Very interesting approach you see here. Of course, at the experimental level, what you use as CO2 source is actually bicarbonate, which solubilizes very well in water. So it's much easier in a lab scale, but of course, if you imagine an upscale of this process, the basically is to use, let's say, real CO2 coming from the atmosphere. University of Montpellier is working on another very interesting activity I already mentioned before. When you produce different VFA, then you will have different PHA. And an important part here is try to produce medium length molecular weight PHA. So this will enlarge the portfolio of different possibility. You have different properties for these bioplastics. So let's say something more rigid because of instead of something which is more elastic. Or so you actually have a portfolio of different polymers with different characteristics which can be used to produce different products in the very end. Coming to task 2.4, University of Santiago de Compostela. Again, another application here. They are using processing wastewater coming from, let's say, seafood industry. So very important here. Of course, you need bugs which are able to stand very, very high level of salt, of course. So very, very particular. In this case, they are using food processing wastewater coming from mussel or tuna working. And you can imagine, because of the number of countries having long coasts in Europe is a very important strategic point, touching the part of the so-called blue growth, which is an important part of the European policy in terms of growth, not only for the rural areas, but also for coastal areas, which sometimes are suffering, with the exception, of course, of tourism. The rest of the coastal areas, all the other activities like fishery are suffering a lot in this year. Also, the guys in Santiago Compostela, they will work also on the development of a model for the production of VFA and optimization of VFA and transformation into PHA. Coming to the upscale, what is actually in our hands directly through Innoven company. Well, there is part of this pilot plan was already realized along different EU projects, some of them also BBI. What we are doing now is actually redesign all the line and try to change some of these steps in order to improve the efficiency of the system. But the basic idea you see here is that we feed the material coming from the food bioprocessing. You ferment this material, you produce a fermentate which can be separated in a solid material, which is going to biogas as usual, and the liquid fraction reaching VFA will be cleaned up and then used into SBR system working with a mixed culture, like the system we already seen at the University of Rome, which is actually the owner of the patent of this system. And after that, you have the extraction of the PHA, and you produce material you see down in the corner on the bottom of this slide here. You can see the material, okay, you recover the PHA. It's clearly quite a bit dirty, so it's something not really fantastic for the guys of the polymer sector and plastic sector. So of course, what you have to do here is improve the quality of this material, which is still full of impurity, let's say around 20% of impurity and salts, basically. So the last part of the work package will be actually dedicated to extraction and purification. It is in the end of the guys in Belgium, BBIA, so the bio-based pilot plant based in Ghent, basically. So what we will try to do is define a protocol where you can use green solvent extraction in order to pass from a low-grade PJ, like the one we are producing now, where you have 80% purity, to a material with a 90% purity at least. So in that case, it will be more interesting and sexy also for the guys from the plastic industry, actually, to produce some material. So I really thank you. I try to keep it very simple and very fast. Hope you understand everything. And of course, I'm available for questions.
Thank you, David. Please make sure you send me the PDF of the presentation.
Sure.
Alison, would you please activate the microphone of Iris Anderson, who has a question. She's raised her hand. She has a question for us. Iris, you will need to unmute your microphone, and we are activating your microphone now so that you can ask David your question, please.
Hi, everybody. Well done. Some great presentations. I was very excited to see the new products, David, especially the straws, because we have had many bio ladies who work in the procurement side asking about new straws. Will the I know you're still in the middle of the project, but will some of these new products be sent out so that we can start already telling the procurers that this is coming up?
I think really this is a question for Jose. Jose, if you are still on the line. This is where, Iris, we had our contradiction, and this is where we talked about the schizophrenia before, because under the single-use plastic directives, plastic straws are banned. And also the UK law will ban plastic straws from, I believe, next year. The British single-use plastic directive will come into force, law will come into force. Now, what do you call plastic? And this is where the discussion is around, because even natural-based or waste-based polymers such as PHA are currently in the draft EU legislation defined as plastics. And therefore, we will be making these beautiful biodegradable, compostable, bio-based, waste-based straws, but in June 2021, they will be illegal. Okay.
Yes, I know, but since in the UK we're now out of the EU, we might be able to influence to use some, especially in closed events. I was just thinking about Glastonbury, which has been in the news so much, which will be even bigger next year. Something like a closed event where we know that they actually understand composting and stuff like that. That even if it's trampled into the soil, they will then biodegrade.
Naturally, we are doing our best to make sure that the UK government understands that. And regardless of what goes on in Europe, we do have now the ability to make our own judgment on that. But we shall see how that works out, Iris. I think at the moment it's a little premature to say that we have those materials available on the market. But that's a question for Jose that if he's online can come back to us. Meanwhile, while we're waiting for that, thank you for the question, Iris. Let's go to our last very short presentation from Alessandro Caffagnini. Alessandro, are you there? If you are, thank you, David Bolsonaro, for the presentation. If you are there, Alessandro, now is the time to appear. Put your video and your microphone on and share your screen with us. Alessandro. Dove sei? Where are you? There we are.
Here we are.
Here you are. Okay, good. Welcome, Alessandro. Alessandro was also a partner. You need to put your video on so we can see you as well. We can see you. Alessandro was also a partner in the, there you are, in the Res Urbis project, which finished last year. And so we've been working together now for more than, well, 4 years, I think now. And Alessandro is going to talk to us about his work package very quickly because we're very late, Alessandro, 10 minutes maximum. Thank you.
Okay, I will be as fast as possible. Thank you everybody. I will. So basically, as we know, this project is about converting this bio-waste into packaging. One of the challenges is, and here you can really see pictured exactly in a visual form the objectives of this polymer. What is not really visual is that one of the achievements is to really get to the point that we deeply understand the functionalities of the articles that we want to go and substitute and actually match exactly the same functionality with the novel material obtaining from wastes. This is a key point of this project, and in order to provide a real alternative to traditional materials and in order to bring a real advantage to you citizens and to all what is connected to the managing of wastes along within Europe. So in order to have this technology working, and in order to have this to be minded to have this our product on the market, they have to work as much as possible or completely, so clearly no compromises on functionality. So basically the packaging item must work based on made of PHA materials coming from bio-waste, must work exactly as the equivalent from traditional fossil-based polymers. So in order to do this, we are undergoing a very important process of understanding and gathering all the specific information of each packaging and understanding which are the key points, the key functionalities that the end users and the food producers need on both on the side of the approach on the packaging production and the packaging filling of the article, of the packaging article, meaning, and on the side of the end user, which needs to have exactly the same user experience of the product, which is could be a biscuit, as we saw before. We saw forks, knives, glasses, and the number of applications we are analyzing. So this the work package first one and the work package 4 are bridging the one to the other one, because in work package 1, as we saw before in Fabiana, in the presentation of Fabiana, is about gathering all the functional informations about the packaging article, and then in WP4 all of these information are packaged in order, are recollected, let's say, in order to provide information for the redesign or for actually making properly the packaging, so to obtain the same functionalities. So we can say that WP4 has started a few months ago, so we are at the early beginning. So we are in this process of gathering all the information and working on that in order to produce useful information for designing the novel packagings, and that really are characterized from with the same functionalities. Here we can see, I just wanted to make to show evidence about which kind of to the kind of tools we have been using. We developed a paper, which is a document, which is a packaging analysis sheet that contains that is filled with the information from the food industry, that gather all the needs of all the requirements for the packagings and that are currently used in order to really to make us from what to gather the information that we need to know before we start producing or before we start designing the material. So this was just a brief example of a document that is and the source of information that it will be used, and it is already in use for designing the materials. So I was asked to be very brief. So this is all for the moment. These are the first part. What I showed so far is just the very first part of the objectives of UP4, is what we has just started, and it is assessing and retro-engineering the performance of packaging needs. So this is summarized in the slide we saw before. So
Alessandro,
that's all for the moment.
Can I ask you, Alessandro, are there any criteria for which these materials have a superior performance to traditional materials? For example, if you've analyzed the machine biscuit packet which Barilla are using, do you think actually on any characteristics that using these innovative materials can improve any of the characteristics, or is it a struggle just to meet them?
No, I want to underline, this is the strong point of this approach, is just that we had the opportunity. The last paper of this document contains let's say a wish list from a wish perform a property that is considered desirable, and it is not attended from present packaging. We decided and we put this last part in the last part, this box, because we saw that it is very possible that packaging produced with PHA may have surely different properties, and some of them may be appreciated and better than the one of traditional materials. I just give you a rough example. It's and it's one of the, but which has a strong meaning for these purposes. Some packaging is at the moment is produced by specific polyolefins, which are coming of course from oil, and it's very hard to put ink on them and having the ink sticking for a long time, and you know, labeling and all of this is require additional process. If we use PHAs, we probably are able to make much more simple the labeling and marking of this packaging, and this is a great advantage because it brings a save of cost when you produce the packaging, and brings an advantage for the supplier. And this is just one rough example of one of the potentialities that we are exploring and that we have already seen in the very first analysis. I hope I replied to your question.
Yes, thank you very much, Alessandro. Now, we've finished the presentations. I would ask all the speakers who are still with us to come back online, because there are some questions which people have sent in, rather than questions which I've asked people to raise their hands so that they can ask the questions directly, but they've actually emailed them to me. So if you have a couple more minutes and are patient, then I will ask these questions to you, and whichever of you wishes can reply. Firstly, from David Berriman. David Berriman here in the UK is a big fruit juice producer. He asks, will the project, or does the project work with established packaging companies such as Tetra Pak? Well, I think the answer to that, Jose, is yes, we are working with established packaging companies, but maybe you would like to specify.
Yes, correct, David. We are working, of course, within this very nice stakeholder platform that you have put together for the project. There are a lot of different packaging companies of all sizes, and outside that, remember that in fact we are 24 partners, but we are also not working only on this project, but we are also participating in other projects. So the outreach of the activities that we do is very vast at the moment. So there are a number of large packaging companies involved and also smaller ones, etc. So there are many examples.
Okay. Yes, the presentations to answer all your questions will all be online shortly. A couple specific ones from Emily Nichols, who is a board member of BBIA, but also responsible for the compost and AD industry within the Renewable Energy Association here in the UK. She asks, will you be evaluating the PHA performance on biodegradation in wet AD conditions? So mesophilic wet AD conditions. The reason she's asking this question is because in the UK, much food waste is going to wet anaerobic digestion rather than, as in Europe, going to dry or mixed AD and composting. And so she's concerned that these materials will go onto the market and literally end up in incineration or landfill because wet AD will not accept them. So the question is, will we be making those tests?
As far as I know, we will be making tests in soil, marine environments, and then we'll also assess the home compostability and the industrial compostability. So these are the four type of testing that are underway. If this additional test or this test is not falling within this range, we can certainly discuss it internally and carry out those tests as well.
Yeah, it's a specifically British thing. Yeah.
David, just let me add that as Chema mentioned, we are also working other projects. In one of these other projects, we are working on this side, which is testing. And of course, PHA degrades very well in wet condition anaerobic digester, a bit slowly, frankly speaking, but it degrades. So imagine you can work at 20 days retention time as sometimes we do, but if you work in 30, 35 days, of course, the material disappears. So I really don't see great problems in this sense.
It would be very good if you could share those results with us, David, because I think that people would like to see that, particularly here in the UK. The next question from Rob Elias up at Bangor University is, what strategy will we use to reduce the cost of these polymers? Because of course, being in the experimental stage, the cost, of course, is beyond anything that is on the market. So what is the strategy to reduce the costs? Maybe Fabiana would answer this.
The strategy to reduce the costs is to establish circular value chains. So what we are talking about here is to look at the producer utilizing the polymer, the producer of biomass, utilizing also the polymers. So establishing a circular value chain can reduce the cost because first there are less steps in the value chain, and every step has basically a carryover of different. Everyone has their own margin, so having a shorter value chain is basically more efficient, and also transportation costs. So these are the two. This is particular for this project, and of course there is a development in the technology that aims at making the technology more and more efficient, and this reduces the cost. So this is, I would say, more general. Maybe David can comment on that. That's of course the aim of the technology provider to do the operations in the most efficient way possible. But having a circular value chain, of course, reduces also additionally the costs.
There's 2 or 3 questions quickly from Julio. Julio Guzolfi is one of the members of the stakeholder platform as expert on packaging. He asked the question, what is the actual capacity available of PHA, and how do you predict that market developing?
Well, if I can answer that, so we are working right now on applications, and we have guaranteed a supply for 15,000 tons a year of the PHA. There are of course a lot of new technologies coming into place, in which these microbial mixed cultures technologies are right now at the SME scale, but they will, and also within, for instance, the Resurbice project, the idea was to build one of these PHA plants within this municipal waste sort of installations. So there is every day a new let's say news about somebody coming into production, and once these technologies, I think, become mature enough, there will be a supply of all these new PHAs that we are using and we would like to see commercially available. At the moment, there are a handful of companies producing these volumes in this range. I wouldn't know for sure what is the total capacity that they have, maybe around 25,000 tons a year or so, but that's difficult to know.
Sure. We don't have that data. The final question, maybe, Dieter, are you still online with us? Or if, I'm not sure if Dieter is still here. No, I think he's had to leave.
I am actually.
Oh, you are here.
Yeah.
Dieter. Oh, good. Okay, because I can't see your screen. So, Richard Fine, who I think is in Australia, actually. Richard, good evening there. How many projects to date that the BBIA has financed have actually gone to commercial stage?
Oof, that's a good one. Let me quickly think of the 123 projects that we have. No, so if you're talking purely about commercial stage, well, first step there is, I would say, the flagships, for a simple reason that is their sole purpose, you know, to have this first of a kind commercial operation in Europe. Some of them are still being built, so of course, but that's their general purpose. Some of the later flagships were based, of course, on results that came through previous BBIGU projects or through previous Horizon 2020 funded projects. But of course, their correlation and causation, it's sometimes very difficult, because a project might have 3 focus areas. One of the focus areas seems to be the most interesting one. That is the one that you're then building on. And then the question is, you know, do you request funding for that? Or can you do it on your own? Can you find private investment as well? So we have recently published, I think on the 16th of June, the latest information about the impacts that BBIGU has produced until now. So definitely I would like to invite you to go to our website as well to have a look at that fairly short brochure, but it gives a good overview of where we currently are. But to make that analysis of, you know, correlation and causation of, you know, thanks to BBIGU, this specific project has then resulted in that specific end product. Good luck with that. Let's put it that way.
Okay. All right. Are there any final comments that any of you, the panelists, wish to make? I think that the question of these materials being unique in that they come from a circular source, waste feedstocks or byproduct feedstocks going into making packaging for those same products and going back to soil is unique. But we are seeing no policy privilege for that type of material. And that needs to be clarified and worked out very, very quickly. But apart from that, are there any other comments which you, as panelists, wish to make? If not, then I will say we've been here for 2 hours. Thank you to all of you, the panelists, for being with us and dedicating your time. Thank you to the 100 or so attendees around the world who have listened in. I hope you have learned something. I hope you will join us on the stakeholder platform and contribute to the next 2 years of our research and to help us through that. And we will be back in touch with you all, maybe just after the summer with the next round of webinars. Goodbye, everybody.
Thank you very much. Thank you, David, for
Bye.
hosting the event.
Thank you all.
Thank you very much.